Alright folks, today we are going to talk about acids and bases and salts, specifically titrations. You will be doing a titration lab. So a lot of what this video is it is actually demoing the lab for you so you see how to do a titration. Okay, so that's a lot of what we're going to do in here. Right. The first thing you need to understand is titrations are all about standards. Somehow when you think about standing on a scale, how do you know how much you weigh? Well, someone had to figure out how much a pound was, right? And you don't know who that is, and I don't know who that is, but someone had to figure that out, right? And we have to make sure that all of our scales are calibrated the same. So if you stand on one scale and you weigh a certain amount, you're going to weigh the same amount when you stand on another scale. We talked about that a lot when we talked about temperature. Well, when you have scales, what you have is you have little weights down here, and all these weights, these are very, very precisely measured. So when you're actually doing a balance, you might say, well, I put some over here to balance off whatever the amount of stuff is that I'm putting over here. So you put the weights up there to figure out how much it balances off to. Okay, that's called a balance scale. And we have lots of weights to be able to do that, and they are very, very, very precisely measured. Okay, so you don't even touch them with your hands, you pick them up with forceps. Right? How do I determine the concentration of a solution? Well, if I make it, that's pretty easy. So let's say that I'm making a solution of sodium hydroxide. I can figure out how much sodium hydroxide weighs, and if I wanted to make, let's say, a 1 molar solution, I'd figure out exactly how much that weighed, and if I made 1 liter of it, then I'd put in 1 mole of that, and then I'd fill it up to my 1 liter mark. Actually, I'd use a volumetric flask, all right, and fill it up to that line, right? That's pretty poor drawing, isn't it? Anyway, all right. Okay, so you get this, you can do that, but what happens if I have a solution, all right, in, let's say, an Erlenmeyer flask, and I have no idea what its concentration is? How do I determine that? Well, what I have to have is I have to have a standard solution. I have to have a solution that I know. And if I'm working with acids and bases, if I have a base that I know, I can figure out the concentration of an acid, an unknown acid. Or if I have a known concentration of an acid, I can figure out the concentration of an unknown base. So I need to have or make a standard stock solution of a known concentration. So a standard solution, you might want to write this down, is a solution whose concentration is accurately known. And we have these in the stockroom. We do this a lot because we need standard solutions to be able to prepare solutions for you so that you can do labs. Right? Now, we can use this solution of, let's say, a standard acid to determine the concentration of another solution, let's say an unknown base. Or vice versa. We could know the base and not know the acid. Right? So when we do this, we have to come to the point where we have something called an equivalence point, and this is where the solution is neutral. So again, write that down, what an equivalence point is. So pause the video and do that. So when we take an acid and a base and we put them together, we get water and salt. Remember when we used the universal indicator, it turned green? Well, we also have something called phenolphthalein solution, which will go from clear to pink, okay, or pink to clear, when you hit that equivalence point. Or actually, it's the end point. The end point is the point at which the indicator changes color, and it's extremely close to the equivalence point. So for purposes of what we do, we assume that the equivalence point and the end point are the same for when we're doing math. Now, in all honesty, they're not, but they're really, really, really close together, so we assume they're the same. All right? So what that means is all of the hydrogen ions that are donated and the number that are accepted are the same. In other words, you have a pH of 7. All right, so our conceptual understanding, let's talk about this for a second. If I had a 1 molar solution, let's say 1 molar solution, and this was a base, let's say, and I had 10 milliliters of it, and if I took 10 milliliters of an acid over here, and I mix them, 10 milliliters, and I mix them together, and I got right to that point where they changed color. If it took exactly 10 milliliters of the acid to offset 10 milliliters of the base, then that would tell me that they have exactly the same molarity. They're just as concentrated as each other. All right. Now, what would happen if I had 10 milliliters of a 1 molar base, and it took 20 milliliters of acid to offset the 10 milliliters of base? Well, this took twice as much, right? So if this took twice as much, then it can only be half as concentrated. So the acid would only be half as concentrated as the base. Let's use that same concept where here I have 10 milliliters again, and this is 1 molar, and that's my base. Still, the bases are over here. Over here is my acid, but over here I've only got 5 milliliters. Well, that tells you that this is twice as concentrated as the base is to be able to offset it. Right? So that's the concept of what we're doing. So when you do an acid-base titration, it is a carefully controlled neutralization reaction. Now, what you saw in the last podcast was a very not carefully controlled neutralization reaction. Here we're going to carefully control it. We're going to use a standard solution of a known concentration, which is going to go up here in our burette. And we're going to put an indicator in here that is called phenolphthalein. And phenolphthalein indicator is clear when it's in an acid, and it's pink when it's in a base. And right when it hits that neutralization point, that end point is right at it's almost right at the equivalence point. At that point, it is neutral. And so that means the moles of acid and the moles of base would have been the same. Right? So this flask would contain the solution that we're titrating. It also contains the phenolphthalein. And then you go and you're putting titrant into this. And you're looking at this saying, I really don't get it. I'm not sure what I'm doing. Well, that's okay. We're going to have a complete video of how to do a titration because you're going to be doing this in a lab. All right. Now, for areneous acids, we talk about stoichiometric ratios. We talk about the total number of moles of acid of H+ ions has to be equal to the total number of moles of OH ions. That's when you hit that equivalence point. That's when the stuff that's in this Erlenmeyer flask will change from clear to pink or pink to clear, depending upon which way you're going, whether you're going from an acid to a base or a base to an acid. In our case, what we're going to do is we're going to be titrating an acid with a base. So we're going to start out clear, and we're going to go to pink, is what we're trying to do. All right? All right, and these are the steps you're going to go through with the titration. So I would suggest you pause the video and write these down. Right, and then you'll see them all in the titrations. You can kind of match what you see in the titration that we do to what you've written down. Okay, so pause the video and write all these down. All right, let me quickly run through them. You're going to clean the burettes with tap water and then rinse them with distilled water. You're then going to rinse them with the titrant. And the titrant is, if you're using an acid in that burette, then you're going to wash the burette out with an acid. If it's a base, you're going to wash it out with a base. You're going to fill them to 0. You're going to see exactly how to do that. And then you're going to measure out the amount of the unknown concentration solution into an Erlenmeyer flask. All right, you're going to add a few drops of phenolphthalein to that Erlenmeyer flask. And then you're going to titrate it with a solution of your known concentration. You're going to put in enough of the known concentration to make it change color, either from clear to pink or pink to clear. Again, in our case, we're going from clear to pink. You'll record that endpoint exactly how much of the titrant you had to add. And then you're going to clean all your equipment. You're going to see how to do that because there's a special way to clean burettes. And then we'll sit down and we'll do the calculations. We'll do the calculations after the demo. All right? So if you haven't written those down, pause the video before you go any further. And then we're going to go with the demo. Here you go. All right, guys, we're going to talk about titration today and what titration is. This thing you're seeing right here is a burette stand. And we're going to be talking about the different pieces of a burette stand. This is a burette clamp, which holds the burette vertically. Now, when you first get your burette, you may find that it is upside down. And the reason for that is it is completely draining, and we want to make sure that it's dry inside, right? But this is the thing that holds the burette. And when you have a burette, you need to be able to fill it. Now, you can't see this. I'll give you a close-up of it in a minute. But up here at the top, which We have to do that so you can see it. Up here at the top, there's a 0. And you're going to fill all the way up to that 0 line. In fact, you're probably going to fill past that 0 line. It's very hard to get it right to the 0 line. You go above the 0 line because you're going to want to drain some out when we get started. Right? But the first thing you're going to have to do is take these burettes and clean them. So that's something you have to do very carefully. So I'll show you how to do that in a moment. All right, folks, the first thing we want to do is clean the burette. So we're going to take a burette, and the first thing we have to do is make sure that the stopper is closed. Right? And then we go and we put some water in it very carefully, because these things are very delicate. And you go and you put some water in it. All right? And this will wash it out. And you turn it upside down to let everything out. And you also should make sure that you open the stopcock to let the water go through it, so that you can actually having water go down to clean the entire thing out. Again, you have to be very careful that you don't spray water everywhere. All right? Now, this allows you to go and give the burette its first rinsing. All right? The second thing you want to do is I would close the stopper. Now, closed is horizontal. Open is vertical. So we want to close the stopper. We want to put in some distilled water. All right? So you take some distilled water, put it in there. All right? Put, I don't know, it doesn't matter, 10, 20 milliliters in there. Get it nice and clean. All right? And then you're going to open the burette so that you actually get water going through it to clean that part out. And then you take the burette and you turn it on its side and you roll it. Right? And as you're rolling it, the liquid, I don't know if you can see this, but the liquid is going up this way. Right? We're actually getting water going up through the, on the inside of the burette, going and washing the entire inside of it. And that's what we want to do. We're going to do that, and the water is going to work its way all the way up to the other end, and that will rinse out the entire burette as you work to the other end. Okay? And then eventually all the water comes out. Again, you can open up the stopper, open up the stopcock to make sure all the water goes out. All right? You have now cleaned the burette. But now there's water in here. How do you get the water out? Well, you don't get the water out. All right? We're going to replace it, and I'll show you how to do that in a second. Okay, folks, so now what we're going to do is we're going to work with our base. All right? So we're going to put it back in our burette stand. We are going to make sure that the stopcock is closed completely after making sure there's nothing in it that we can get out. Okay? All that distilled water is now out of here that we had, but there's probably still some residual distilled water in there. All right? So what we do is we take our burette, and you can do this many different ways. Let's see if you can actually see up there what I'm about to do. You can't. Okay, there we go. Up here at the top of my burette, I can go and put liquid in. Now, in my case, I'm putting in, this is going to be the base that I'm putting in. Right? And I'm going to pour it in. Now, you can use a funnel, which I would suggest. I'm just too lazy to use a funnel. I'm putting in about 10 or 15 milliliters of liquid. Now remember, the stopcock had to be closed before you did that. All right. So now what I have is I have some base in here. Now I do want to run a little bit of the base out through it, just to clean out any distilled water that's in there. All right. So I clean that out, and I do want to leave some in there because that's expected. Now in here I do have some base, and I'm going to go turn this again on its side, and I'm going to rotate it. All right, in an effort to clean the inside and get only base on the inside. So the base is essentially washing out all the water that's in here. And it's eventually going to roll out of the top when it comes out. Okay? So it's actually rinsed the entire inside, and now what I'm going to do is I'm going to just turn this open and let it drain out into the sink. So I'm letting all of my excess base drain into the sink. All right? Because that has probably a little bit of distilled water in it, so it's not as concentrated as it should be. Okay. So once that finishes draining, I don't go and shake it or anything to get the last out of the inside, because that'll come out anyway when I put in my real base. Okay. Now what I do is I go and I fill this up. Now that it's clean, I can go and fill it up. Again, I have to be careful doing this. I don't want to get this stuff all over me. Okay. And this is going to be my base. Now I'm going to do exactly the same thing with my acid. Right? And one of the things is, one of these is going to be a known concentration, and one of these is going to be an unknown concentration. And remember, when you're filling it, you fill it up to above the 50 milliliter line, right? And then what you do is you put it back in your burette stand, right? Now, then what you need is a waste container. And I did not prepare well, so I'm going to go get one. Okay, folks, I have my waste container, which is going to be a beaker. And the reason I'm using a beaker and not an Erlenmeyer flask, all right, is because it's a different shape. So it's very clear to me that it's a waste container. All right, I open up my, my stopcock just a little bit to let some liquid go through here, all right, to clean that out. Now, what I also have to do is look up at the top of this, which again you can't see right now because I want it to get to exactly 50 milliliters. So I'm going to open up my stopcock, and a lot of the ways to do that sometimes is you just flip it really quickly, all right, and that lets out just a bit of liquid, all right, and then when you get to the point where you have to get just the last little bit out, all right, you turn this very, very slightly, just barely enough to get some liquid to come out, and it's going to come out drop by drop, right? It's not going to come out a lot at a time. That was too much. Right, it's going to come out a drop at a time is what you want. So let me show you what that looks like. Come on, drop at a time, right like that. All right, so that you can control exactly when to stop this thing. Right, and then you can stop it at exactly 0. Okay? Guys, I realize you can't see that very well, but that top, the bottom of the meniscus is right at 0. All right, and that's what you want to end up with by going and turning your stopcock very slowly to get what you want. All right, well, now that we have done that for the acid side, which is over here, we're going to do that for the base side as well. We're going to clean this out. I'm not going to waste your time doing it, but we're going to clean this out exactly the same way we did with the acid so that we are ready to work with an acid and a base. Okay, make sure that you label each of these. You tend to do that up the top where you put an A or a B at the top of the top of the burette stand, the top of the burettes. Okay, folks, over here on the right, we have our acid. All right, now the acid is an unknown concentration, and we're trying to determine the concentration of our acid. So what I'm going to do is I'm going to put exactly, let's see where my 20 is. All right, there it is. I'm going to put exactly 20 milliliters of acid into my Erlenmeyer flask. All right. So now you'll notice that the burette all the way at the top reads at 0 and all the way at the bottom reads at 50. So as you're reading down, you can just stop when it gets to 20. All right. So far I'm only at about 9. There's 11. All right. So what we want to do is get exactly 20 milliliters in here so that our math is easy. Now you can put any amount that you want. It can be 10 milliliters, 15, 15.2. It really doesn't matter. All right, but I'm going to try and get as close to 20 as I possibly can, just because that's a nice round figure. All right, and I'm going to slow it down so that it goes drop by drop, so that I can get exactly 20. And I am now at exactly 20. All right, so I touched the Erlenmeyer flask to the tip of this just to get that last bit of liquid off. Okay, I now have exactly 20 milliliters of my acid. And I'm now going to take the base, and I'm going to titrate against the base. Now, what happens when we reach our equivalence point or neutral? We talked about phenolphthalein in one of the podcasts. I'm going to put a couple of drops of phenolphthalein into our acid. All right. Now, when you put phenolphthalein into an acid, it just stays clear. It doesn't do anything. Okay. So what we're going to do is we're going to add our base because we are titrating against the base because we know the concentration of the base. All right. So what we do is we start putting base in, and we can start putting it in pretty quickly, but you'll notice almost immediately we've got this pink color sitting in there. All right? But when we swirl it, the pink color disappears. All right? And the reason for that is right where the base is going in, phenolphthalein turns pink in a base. So we are turning pink in that little bit because we're adding a base. All right? So far we've added 10 milliliters of base. And you'll notice that pink is staying around for a while. So we're getting slightly close, but not very close to that equivalence point where we have reached the same number of hydrogen ions as we have reached OH ions. All right? All right, so we're getting closer. All right? Let's see I'm going to see if I can bring this camera in a little bit so you can see this better. Alright, so I want you to be able to see as I'm doing this that I'm still adding the base, and I want you to be able to see the color pink as it's starting to show up here. Alright, let me see if this helps a little bit. Put that behind it so maybe you can see it a little better. Alright. Now, the concept is you do not want to go past the equivalence point. So you don't want to go to the point where this thing turns completely pink. Alright, so you're trying to be careful as you do this. And it's real tempting to just go very quickly, but you really have to go slowly to let it turn pink. Now the problem is that means this podcast could take about 2 hours. Alright? Especially when I start going drop by drop, which is what I'm doing now. Alright? There will come a point where this thing turns just ever so slightly pink. And that's your equivalence point. That's where it is making the change from clear to pink. Right? If you see this, you can see that it's going drop by drop by drop. And as that pink starts to hang around a little bit longer, you're getting real close to the end point. Now, since this is live and this is not Memorex, I have absolutely no idea how long this is going to take. Right? I don't know if I need 5 more milliliters or 1 more milliliter or what, but you'll notice that pink is hanging around pretty long. Right? Now, what happens if you do go past the end point? All right? What happens if you do miss it and you go all pink? Well, that's okay, because you've got your acid sitting over there in the other burette that you can go and add. So if by mistake you go too far and you go to just solid pink, I'm coming real close. Right. At that point you can go and add a couple of more drops of acid to go back to clear, and then do it again, and it'll only take you 1 or 2 drops of base to make it. And then you can go and do your math, and we'll show you how to do the math for figuring out the concentration of your acid. Remember, we know what the concentration is of the base here. All right? So, anyway, I am going to, we'll get there soon. Got to get there soon. Almost there. So you have to be patient. I understand you may not want to be patient, but you got to be patient. All right. I'm almost there. I just put it in a bunch and didn't get there yet. Getting very close, very close, very close indeed. All right. And you notice I have a barely pink color. Oh, the pink color is gone. Maybe 1 more drop. Okay? So you want to get real careful here, because you all right, there we have that pink. Okay? Pink is staying around for a few seconds. It's still there, it's still there. It might stay, might not. Looks like it's there. So I have just barely a color pink. All right, certainly 1 more drop will give me, there we go. That 1 more drop will give me a definite pink. So I have found my equivalence point, and that took 30.20 milliliters to make it there. All right, so now we can do some math to figure out what the molarity of our base is, because we knew what our acid was. All right, so we'll go back to that in just a second. All right, there are the titration steps again. If you didn't write them down, make sure you pause the video and write them down. And you should have seen each one of these steps as we did it in the titration. Please remember to clean all your equipment when you're done. That's very important, so that the next person is able to go and use the. All right, folks, that's the end of the actual titration part. What we're going to do is, in our next video, we're going to go through the actual calculations of what you do with that information now that you have it. Okay, that's actually how you do a titration. If you have any questions about it, please make sure you ask us before you sit down and do the lab. Okay, it is very important that you do it correctly. All right? We'll see you in class. Have a good one. Bye-bye.